we're going to talk a little bit about space-enabled thinking. It's actually something we found out by coincidence by working with very passionately about space. And especially space architecture, that's what we do. So this is a picture of space. I mean, you can look at this picture, right? And we understand, like, logically that is space, but it can be very hard to really feel that is space. This is really abstract to look at. So if you, for the next 10, 15 minutes while we talk, if you really try to understand that space is actually right there, like we are in space right now, then that will make the next 10 minutes more interesting.
And it looks really peaceful as it is there, floating in this vast darkness. But actually, if you think about space, yeah, Earth is peaceful. It's made for humans. But when we have to go out into space, when we have to explore it, it's a much more hostile place. And there's really little room for error. So this is also a picture of the Earth behind Saturn. So Earth is right there. And it's taken by a Cassini probe, which is a spacecraft that traveled very far out into the solar system.
And this is a picture of the first ever spacewalk.
USA.
And I think it's a beautiful picture, but the reason why we put it there is because the foundation of this space thinking is really that there's no place for bullshit, right? It's very rare that you work with something where there's no buzzwords or there's no room for bullshit. But this guy, if there's just like a tiny little mistake in a spacesuit, then he dies, right, immediately.
In space, bullshit kills you.
Exactly.
So, in 1999, this spacecraft, $200 million, was launched to Mars to study the climate, and when it arrived, it just crashed right into it. So why? Because of bullshit, right? So the American scientists, they didn't bother to take their miles and convert them into the scientific standard of metrics. So they completely discalculated it, and now it's just a piece of space junk. USA. So, USA. So just to highlight that there's something unique about space that means that you have to provide the very optimal solution when you go there.
And this is actually the thing that we just saw fly over. So this is the collaboration. This is like a $200 billion international collaboration, and there's 6 people living on this thing, and it's an engineering masterpiece.
It's probably the most beautiful piece of engineering that humanity has created. You know, the whole world has been involved in building it. We have Russia working together with the USA. USA. Sounds so patriotic now. Yeah, but it's quite unique, right? But it's an engineering challenge, and we're architects. So
what does architects have to do with space, right?
Exactly.
And so there's one architectural addition to this thing, and it's the cupola. It's kind of probably the most beautiful window in the world ever made by humans, and it looks down on space. And this is a picture of Samantha, who is an astronaut, and we had the chance to talk to her very briefly. And she said, like many of the other astronauts, that this is actually her favorite place on the International Space Station.
And we did not land just from the ISS.
Unfortunately. But so they spend their time there taking pictures when they have a little bit of free time.
So you could say, in a way, that engineers make sure that humans survive in space, but the architects make them thrive. They make sure that there's something, to experience, and that's where they are.
This is a picture of Karl.
This is a picture of me.
In the desert. No, but so tabula rasa is this Latin word for a clean slate. And that's actually, if there's anything that you take away from this talk, just don't remember the Latin, but remember the note. Remember what?
Remember me.
Yeah, remember Karl, the tall alien. Remember no assumptions, because that's really what we are trying to stress here. And by no assumptions, we mean, so it's really challenging when you design something on Earth. You kind of bring your culture, you kind of bring everything that you have known and what your friends think and all these things. But if you design something in space, you really need to start from scratch every single time. Otherwise, you're going to fail.
If you try to look at Mars from scratch, it's about taking those fundamental conditions that are there and analyze them to inform a habitat or a lander or something that we put there. And the idea is that we have to do that when we go to space, sure, but we can do that on Earth as well. But I'm just going to try to describe to you what is on Mars. One of the things about Mars is the radiation. So there's no magnetosphere and there's very little atmosphere. So you're being bombarded by cosmic radiation, which is quite dangerous. So that's a problem there. There's no breathable atmosphere and it's very thin, as I said, around 1% that of Earth. There's a lot of dust. There's actually right now a global dust storm that is covering the entire planet, like shielding out 99% of all sunlight. So if you were to put solar panels there, and there are solar panels right now in the rovers and they're having serious troubles, you can see it doesn't work. You have to think more carefully about this. It's smaller, gravity is less. I would weigh 30 kilos when I go to Mars. And it's very far away. It's so far away that a signal traveling there takes around 20 minutes just to reach there. So if I'm there and I write a text to my girlfriend, it's going to take 20 minutes to get there. She's going to reply 20 minutes back, so 40 minutes later, if she replies instantly, yeah, that's great. Then I'm free for 40 minutes. No, it's a challenge, right?
We designed this habitat for Mars. So we go there and we try to bring no assumptions, right? So we look at the conditions, we look at the dust, we look at the sun, we look at the light. Mars is very dry. And we look at all these small things and we look at them completely objectively. And I think this is something that you could use for many other fields as well. And then we look at them and then we say, okay, what of these conditions could we make into features? And maybe take something like the dust, which really doesn't work because NASA, they brought like their solar cell assumptions to Mars. So, okay, now I'm being really cheeky, right? But instead we thought, okay, this fucking dust, can we turn it around and use it for something useful? So we came up with this concept.
So the idea is that we use the dust to create something called triboelectric charging.
And what he's trying to say is we create electricity.
Triboelectric charging, also known as static electricity, happens on Earth when you shuffle on your feet on a carpet and then you touch something out of metal like a doorknob and you get a little sting, right? It's not a lot of energy because on Earth there's humidity in the air, so the charge escapes through there. The ground is conductive, again, it bleeds out. But because of those horrible conditions we mentioned before, there's very little atmosphere, it's super dry, super cold, there's a lot of dust. All this charge, it just keeps accumulating. And we noticed this, and we noticed that NASA had to invent all kinds of new technologies in order to get rid of this charge from the rovers because it was interfering with the electronics. We actually thought, why don't you just, increase the surface area by making this spiky furriness so that you have many more particles and then you start using the dust for something positive. You actually will be able to charge up your habitat. So in a way, right now, when there's a global dust storm and the sun is gone, it might be a time for celebration because then suddenly you have abundance of power. So that's a key idea that we used here.
Yeah. So the idea is that you spread these shelters all around Mars, kind of like protective shelters in the mountains here on Earth. So you're always within some kind of safety and rest on Mars. And we were inspired by this beautiful idea of a dandelion and how it kind of floats in the air and then unfolds into this structure.
So it's called the dandelion shelter, actually.
Yeah.
So yeah, there's some other things about it. We try to be really efficient. So using principles of stacking, we thought you could pack 20 of them in one, say a Falcon Heavy launcher, and then fly them all up in one go. So then they'll arrive as this dense package and then scatter out and deploy. And when they then land, it's this little package, like the dandelion seed, and it starts integrating with the environment. So it'll pump up with air to unfold, like the Bigelow Aerospace inflatable habitats that we talked about before. And
And
then,
yeah, and over like a long time, it will kind of start filling up on dust. So again, kind of using the dust because of the radiation, you really need protection. So the dust will fall into these valves and collect in the walls, and that will become your radiation shielding.
so it's kind of like a little Martian organism that lives off the environment, just like plants live off the environment here. And it wouldn't work on Earth because the charge would bleed off, you know.
This is a section of what it looks like. So you have the wall, and then you cut right through it, and then you can see the spikes. And
yeah, so that would be the membrane that the dust comes in and fills up, because you need some sort of barrier to protect the radiation, else you get cancer really easily. Not good for a long-term settlement, right? 1,000 people on Mars would quickly be wiped out. Yeah, just another look at the inside. It's a cutaway drawing where you can see two very happy astronauts laying inside, enjoying the time. And in the top, because it also has to provide, you know, oxygen and nutrients. So how do you do that without bringing massive tanks and like buckets of food? You can actually use algae
and water.
So you make an algae, it's called a photobioreactor. So this algae, it just needs light, and it'll get that, you know, via the energy that is being produced by the dust. It needs light and CO2. Humans provide CO2. And then, you know, the biomass, it starts to grow, you get nutrients, you can actually eat the algae, and it produces oxygen. And water is one of the best radiation shields that we have. So we place it all in the top of the dome so that it protects from the most dangerous sources of space radiation.
Yeah, so this is a picture of before. Yeah, so right now, like we talked about, there's this problem about the dust on Mars. So this is an actual picture from a rover on Mars before and after a dust storm, and you can see how thick that dust is, and it can encapsulate huge parts of Mars for several weeks, several months, and almost no light can get through. Just to sum up, we would go so far and say that you can actually do space architecture on Earth as well. And this is kind of our point on planet Earth, if you want. So I think this is a great example of really looking at the unique conditions that you are building a shelter for. So this is a picture of an igloo. And I think it's so beautiful that the only thing that you need to bring is kind of like a shovel and an ice saw. And then you can build this perfect structure.
Yeah. So those same things that we talked about before, with looking at, you know, the fundamental facts about the climate in, say, an Arctic region. This is like the piece of space architecture you would come up with.
Exactly.
And we think, you know, you can use that sort of fundamental thinking on anything. Like, if I were to build a new government on Mars, I'd probably make the most beautiful government that has ever existed, and maybe that could be used on Earth too.
This is our final slide, and we thought, so if people were gonna remember this little collaboration, what identifies me and Karl, and we thought if you stretch one side and if you stretch the other side, it will kind of be like that. Okay. So, all right, but that was it. Thank you very much.